So I'm excited to share with you that my first modular cookbook is finally available in physical form. You can see this here. It has 50 patching ideas and techniques, of course, with patch diagrams and everything. So you can really explore composition, sound design, creating complex modulation sources. And you can see here it says eurorack and beyond. So in this video, I want to show you 3 techniques. We will explore one technique with hardware eurorack, another technique with VCV Rack, which is a eurorack emulation, and another technique with a modular environment of Bitwig called the grid. And we will start with hardware. The technique I chose here is called random notes per step. You can see there is some text about it, and then there is the diagram that shows you the signal flow of the basic idea. And this idea is all about taking even a simple repetitive sequence and then adding some variation to it, some movement together with random notes. And we will be able to choose exactly on which steps of the sequence we will want to add this randomness to. So we have some stability, which is always nice, but then we are adding some movement and variation with randomness. And here I have the Verbos voltage multistage sequencer. It's set with an 8-step sequence. So this will generate the repetitive stable sequence. It sounds like this. Right, but now we can use this technique to add some randomness to it here and there and make it a bit more interesting or complex. Now for this we will need a random source, and there are many modules you can use, of course, to generate random signals. In my case, I'm using the Octone sequencer. I have here 8 steps set, but it's running, as you can see, it's jumping between the steps more or less randomly. So this will generate our random source. And we need a way to mix both signals, the repetitive sequence and the random signal. In my case, I'm using the Hex Mix VCA, which is also a mixer. So I have once the repetitive sequence and once I will use the random sequence here from the CV output. Right, and now I can mix it in. Right, and now basically we get a random sequence because I'm mixing them on each of the steps. Right, but of course the Hex Mix VCA is also a VCA, so I can use another signal to open and close the VCA for the random voltage and then bring in this randomness only on specific steps. And also here there are many sources you can use to open and close this VCA. You can use a dedicated gate sequencer. You can use a clock division. In my case, I will use the second row here of the sequencer of the multi-stage, so I can select exactly on which steps I want this random voltage to go through. So again, this is how it sounds like now. It's just random. Right, but I will connect the second CV output here to the VCA, so now we get again the original sequence. But now I can select, for example, 2 steps, let's say the last one and the 5th. Right, so now only on these 2 steps, the VCA for the random voltage will open, we'll let it through, and we'll add randomness to this sequence. I will add some delay to this also, just for fun. Right, so again, we get a repetitive sequence, but there is some variation to it, and we can select exactly on which steps this variation will come in. And this can be also quite interesting with uneven steps, so the repetitive sequence you're using has a different length than the signal or the sequence you're using to bring in the randomness, the variation. Right, here I have a 5-step sequence with a voltage block. Right, just a repetitive 5-step sequence. And now again I can mix it in with some randomness. In this case I'm using the Make Noise X pen for this, right? So if again I bring in the sequence. Right, here I have another channel that is the random sequence, and I can mix it in. Right, so now we have just randomness, and I think this is also the nice thing about the book, is that it gives you the functionality of the modules you should use and not the actual modules. So again, I'm using here Xpen, which is a mixer. It can mix also CV, but it has also a CV input for the level, which is basically like a VCA. And here I have another sequence on the voltage block. In this case, it's 16 steps. So again, the repetitive sequence is 5 steps. And here I have a 16-step sequence that I will use to bring in this randomness only on specific steps. But again, because we have 5 steps and 16 steps, they will meet each other at different points in time. Right, so again, there is some stability, there is some repetitiveness, if that's a word, but still the random voltage is coming only on a few steps and adds variation to this repetitive sequence. Let me bring in also the first voice from before. So now we are in VCV Rack, which is a free emulation of eurorack, so many things work the same as in hardware, and all of the techniques from the book also work in VCV Rack. And actually for each technique in the book, there is also a VCV patch example you can download and experiment with. Now another side note, the graphic designer who worked with me on the book is Pierre, who also designed beautiful modules in VCV Rack, as you can see here, and many other modules. Anyway, the technique that I chose for this segment is from the manipulating control voltage section, and it's about using multiple envelopes for creating accents and ghost notes. This is how it looks like. You can see that we will need a few envelopes for this. Right, one for each velocity level. You can experiment with how many you want, of course. For each envelope, we will need also a gate source. And this can come from various sources. We will see this also in a second. And then we mix them and send them to our voice, right? So here I have this setup. I have 3 envelopes. You can see soft hits, normal hits, accents. I'm mixing them with the VCA mixer. And I'm using the result to open a VCA and the filter at the same time. And I have here a sequencer that has multiple outputs. This is the 8-step sequencer or trigger sequencer from Count Modula. And I have here 3 channels that I can use, one for each envelope. So for example, let me run this already and maybe zoom in a bit. For the normal hits, this will be the second row here. I can have steps 1, 4, and 5, let's say. Right, and then bring the level on the mixer for this envelope. Right, so this will be the level for this envelope. You can see the VCA is opening up to here. Right, and also the filter will open a bit. Right, so these are the normal hits. Then we can have let's say accents. This is the third row on step 7. Right, this will trigger another envelope. Right, and then we can bring this in. Right, these are sorts of accents, and maybe we can also change the envelope to be a bit longer. Right, so the accents will have also a longer envelope. And we can have also softer hits or sorts of ghost notes, if you will. Let's say on steps 3, 6, and 8. Right, and again, this is a different envelope now that again we are mixing. So let's bring this just a bit up. Right, because again we want softer hits, and now I can change this envelope for the softer hits to be even shorter. Right, so we get sorts of ghost notes. And we get a simple 8-step sequence, but it has movement to it, it has variation with 3 different velocity settings. Not only the level changes, also the length of the heat change, since we have control over each of the envelopes. And again, this will work in other combinations. Here, for example, I have just 2 envelopes with Rampage from Befaco. You can see I'm using just the Befaco modules, which are also available in hardware, of course. Right, and I have 1 gate sequence with the max slicer and the max expander for the so-called normal hits. Once for the softer hits, it will sound like this. Right, so again, we have an 8-step sequence, but it's a bit more organic because we have louder hits and softer hits, and the envelopes themselves are also different. The softer hits are shorter than the louder ones. Right, and you can have even more envelopes if you want. Here I have another example. I have here Quart from Nano, which is also available in hardware and has 4 envelopes. So here we can have 4 different hits, and I have 4 different gate sources. So let me run this. The first one is a 16-step sequence. I have here 4 hits, right? So if I connect this from the envelope to the mixer, right, these are the so-called normal hits. Right, I have here Max Slicer again as an 8-step sequence with a max expander for more softer hits. Right, and again, each envelope is different, it has different times. Then I have here a Euclidean sequencer with 12 steps for more softer hits, but they will meet each other at different places, because here I have 16 steps, here 8 steps, and here 12. Right, so again, we get softer notes, but they will always move and sometimes also be mixed into a bit of louder hits. And I have here also the VCV random module that is also available in hardware, by the way, that will trigger the last envelope with probability. This has probability control, right, and we will get sorts of accents here and there. Just like this. So for the next technique, we will use Bitwig, which has its own modular environment, the grid, and also with Bitwig there are many ideas from the book you can explore. This technique is from the sound design section. It will look like this. And it's about using comparators to split the signal into effect chains and add layers and complexity to your sounds. Now here I already have a sequence going. Right, and actually I'm already using 2 more techniques from the book. So the technique we saw with the hardware before, adding random notes per step. Right, so here I have the original pitch sequence, and here I have some random notes that I'm allowing with probability through, in this case, the ADSR module. In Bitwig you can use an envelope also as a VCA. Right, so every now and then we get also some random notes, just like we've seen before with hardware. And I also have here another technique is using sample and hold to get rid of note tails. Right, so the sample and hold makes sure the changes in pitch happen only together with the triggers, which is also quite a practical technique. But now let's look at this technique with a comparator. So here I have a comparator module, this one here. Right, this one will output a gate as long as one signal is greater than the other. So the main signal will be our pitch sequence, right? And actually, you know what? Let's take this from the scope so you can see also. Opalach, you can see also exactly what's going on, right? So this is now our pitch sequence. Right, and in Bitwig, we have to define the so-called threshold control that you might find on other eurorack modules or modules in VCV Rack, right? Here there is a repression from Ritual Electronics. This is a comparator module, and you see we have an input, right? So to this we will connect our sequence, and we have a built-in threshold control, right, that we can use. So in Bitwig, we can use something like the value module to act as our threshold, right? So if I send this to the scope, you can see this is the red trace. I can set the threshold to various points, right? So this will be our second signal. Again, we are comparing the sequence, right, the pitch sequence to a threshold. Right, so if now I take the threshold or the value here a bit up, let's say somewhere here, let's say, right, you can see exactly where it is in relation to the sequence. Right, and now from the comparator we will get a gate whenever and as long as the sequence goes above the threshold that we just set here with the value. Right, so whenever the sequence goes above the threshold, just like here for example, the comparator will output a gate. And now for example, we can say that only when the sequence goes high enough, so only on the higher notes, this voice that we have here already will also go through a delay. Now in Bitwig, we can use again the envelopes as a combination of a VCA and envelope. Right, so here I have the AD envelope and also a delay. Right, so I will send a copy of this voice just like here on the example here in the book. You can see we send a copy of this voice to a VCA, in this case it's the AD envelope, and then to the effect. Right, so I will send a copy to the envelope. Right, and now this will go also to the delay, and I will use the gates to trigger or to gate this envelope. Right, so now we get, thanks to the comparator, we get a gate only when the notes are high enough, and only when they are high enough, this voice or a copy of this voice will go to a delay. So it gives us a delay, but with a bit more clarity since it will only be applied to the higher frequencies or the higher notes. Right, and of course this can work with all sorts of effects and all sorts of chains of effects. Here I have another one, another example. In this case I'm using the opposite or the inverted comparator, if you will. In this case it will output a gate as long as the sequence goes below the threshold. Right, so it will work in this case on the lower notes. And this I'm sending through a whole chain. So again I'm using the AD envelope as a sort of a VCA with an envelope, then hard clipping, a delay, and after all of this, a phaser, right? And again, this will work on the lower notes. Let me send this to the mixer. So as you could see, you can explore the techniques from this book with various platforms. Of course, there are links in the description to where you can get it. I hope you will find it helpful and inspiring. Cheers.